Example of an application of trigonometry. At 3 p.m. the sun has a 42-degree inclination above the horizon. At the same time, a tree has a 93-foot shadow. It casts a 93-foot shadow. And I want to find out how tall the tree is. Well, this isn't too hard. I mean, here's the sun up here, and it's shining light down, and hits the top of the tree, and it casts a shadow at the same angle. So one thing we want to do is we want to find the height of this tree. So what I'm going to do is I'm going to draw an altitude here. That'll make a right triangle out of this shape. And then I want to insert my measure of this angle, 42-degree inclination. So what that means is if you come off the ground and you measure up to the angle of this where the sun is, this angle has to be 42 degrees. Alright, so what we're trying to do is find this height of this tree, this red line over here, and the only thing I know is that it casts a 93-foot shadow, so down here would be 93 feet along this shadow line. So what I'm looking for is the height of this tree, so we'll just call that x. Now, again, we want to label the sides according to this angle. This side, since it's touching the angle and it is not the hypotenuse, this side must be adjacent, and then the other side must be opposite because it's not touching the angle. So what we're dealing with here is this angle, the opposite, and the adjacent, and the function that associates those three is the tangent function. So we're going to say tangent of the angle 42 degrees is equal to its opposite, in this case just x, what we're looking for, over adjacent, which is 93 feet. And then to solve for x, we multiply both sides by 93 and we get x is equal to 93 times tangent of 42 degrees. So if we type that in our calculator, make sure it's in degree mode, 93 times tangent of 42 degrees, it's going to give us a value of approximately 83.7. So the answer to the question is the tree is about 83.7 feet tall.